Okay, so we're going to finish up with chapter 7, and here's where we're going to put all the stuff together. So let me remind you, the probability that something happens, you have to know two things. What's the size of the sample space, and what do we mean by success, the number of successes? You're going to have to pay attention to this one very closely. The size of the sample space is usually pretty straightforward. The number of successes, you have to pay very close attention. And in fact, what we're going to find out is, remember that idea of E and E complement has to add up to be 1. We're going to be using that. So let's say we have 2 students are selected from a class of 8 boys and 9 girls. Okay? And the question at hand is, what's the probability that both are girls? All right, so let's ask ourselves the question. Think of it, instead of boys and girls, think of it as 8 red marbles and 9 green marbles. Okay? And we throw them into one box. We mix them up, and we pull out 2 marbles. And the question is, what's the probability that both are green, for example, right? So the first question we ask is, what's the sample space? Now, where are you pulling out these objects from? 2 students out of these guys, but you're mixing these up, so you have no way until after you've picked out 2 students to know if they're boys and girls. So in other words, if you think of red, green marbles, and you are not allowed to look in that box, you have no idea of distinguishing between the 2 types of marbles. So what this is saying here is, if you think of them again as marbles, blue or green, and you have no way of distinguishing until you've actually pulled out the the 2 kids. So the sample space consists of 8 boys and 9 girls. So if I add those up, I get 17. So that's the size of my sample space. Now, what do I mean by success? It means both are girls. So this one has to be a girl, and this one has to be a girl. Now, question, is this permutations or combinations? Permutation order is what? Important. Combination, the order is not important. Is there any reference to distinguishing between these 2 girls? No. There's not a Betty and there's not a Susan. These are, even though they're different, we have no way of distinguishing. All we care about is, are they girls? And obviously it's not the same one. So there's no distinction between the girls, which means we're going to use the combination formula. So let's think about this. What do we mean by success? Success means we pull out 2 girls out of, how many girls do we have available to us? 9. Let me say that again. Success means both are girls, correct? So that means I want to get 2 out of the 9 that are available. So that means when we do our combinations, we are going to have what? 2 out of the 9. Now, let's go back to our sample space. Now, we are choosing how many students. Remember, we put the boys and the girls together, correct? So we had 8 and 9. We had 17 altogether. And we're picking out 2. That's how big our sample space is. So the size of the sample space is not 8 plus 9. The size of the sample space is 2 out of those 17. So if we put that into our formula, 17 factorial divided by 17 minus 2 factorial, 2 factorial, 15. Remember when we were doing permutations and combinations? I'm going to take the 17 and I'm going to stop it right there. That way I can cancel the 15s. And I'm left with 17 times 16 over 2, which turns out to be 136. Okay. The success means I'm picking 2 out of the 9. Order is not important. So I'm going to have 9 factorial, 9 minus 2 factorial, 2 factorial, and then what? 7 factorial. Stop it at the 7 factorial so you can cancel. So then if I take 2 into that, 2 into 8 is 4, 4 times 9 is 36. And so we get 36 out of 136. Just factor. So 36 is 9 times 4, 17 times 8. We can cancel, 4s, and we're left with 9 over 34. And please leave this as a fraction, okay? All right, let's take another example. So let's think about this. There's a couple things we have to know. What is the sample space? What's the size of the sample space? And what do we mean by success? That's very important. On top of that, we have to know, is order important or is it not? If order is important, you're going to have to use permutation. If the order is not important, you're going to use combination. Let's take a look at an example. We have a basket of tomatoes. So we're at a vegetable stand, and it has 9 tomatoes which are grown with pesticides, and 11 that were organically grown. The customer selects at random 3 tomatoes. What's the probability that those tomatoes, 2 will be grown with pesticides and 1 will be organically grown? So this is what we mean by success. Now, question, what's the sample space? So let's see, I have 9 and 11, which is what, 20 tomatoes. And they're all mixed up. I have no way of knowing which one was grown with pesticides, which one was grown organically. I have no way of distinguishing that until I actually select them, and they're being selected at random. So the number of objects in the sample space is 20. Now we have to figure out, be careful, when we're picking out 3 tomatoes, we're picking 3 out of the 20. Okay? So we have no way of distinguishing between the type of tomato it is. We can only figure that out until after we picked out the 3. So there's 20 tomatoes. Remember, we're putting all of them in one box, and we're picking out 3. There's no distinguishing between one or the other until I actually pick them out and look at their label. Okay, so this is the size here. Now, let's take a look at what do we mean by success. This is very important. You're picking out exactly 2 that were grown with pesticides and 1 that was grown organically. When I see the word "and," it means multiplication. Okay? So success means 2 of them have to be pesticide, 1 has to be, exactly 1 has to be organic. Now if I go back here, 9 of them are grown with pesticides and 11 organically. So 9 of them are grown with pesticides. I'm picking exactly 2. There are 11 that are grown organically, and I'm picking 1 out of those. The fact that I have to have 2 pesticides and 1 organic means multiplication. And remember, there's no way to distinguish between the pesticide ones or the distinguishing between the organic. All you're differentiating is between pesticides and organic. Think of it another way. I've got red marbles and I've got green marbles. It's the same thing. I'm picking 2 green marbles, red marbles out of 9. I'm picking 1 green tomato or green marble out of 11. So what this means is if I take, this is the size, this is all the ways What, we could pick 3 tomatoes out of 20. Big number. This represents what? The number of picking 2 pesticides out of 9. This is 1 organic out of 11. And if you go through the calculations, you come up with 33 over 95.